Okay, welcome back everyone for the day two of game development. Today we'll go through the Bolt plugin, how you can use it in Unity. And before that, we will also look what to expect and how to go through the Bolt plugin because Bolt plugin is basically a visual scripting tool, right? So it is still scripting. So you will have to look through the code of the game and then we will go line by line and make a flowchart in Bolt and create a Flappy Bird prototype in this session. Okay, I will show you how to make a movement script and I will show you how to I will show you the Bolt plugin for movement, and the rest you can do it by yourself. If you have any issues, you can ask. Okay, I will start presenting my screen and I will start this session. Okay, so let's start with the first agenda of this session, what we will be doing today. Okay, so what we'll be doing today is first we'll see how to work around yourself in Unity, right? So you are efficient in working in Unity and creating your game. We will also go through the flowchart which we had in the previous session, and I hope you have made you have tried to make your flowchart for your favorite game. If you haven't, don't worry. We'll just look how you can make the game, and we'll send the YouTube link for understanding the game, understanding the session again if you have any doubts. We will also make a simple prototype, not a high-level publishing game. We'll just make a simple prototype with a simple bird image and all this stuff. Okay, so let me show you how is the Unity workaround goes around. Okay, so let me show you the scene. Now, see, this is the scene window as I have shown in the previous session, previous week. So this is the scene window, and if you see how did I make this screen as a mobile screen, you can easily go to this top over in the game view. You can go to 9. You can change free your Unity might have a free aspect ratio, so it will automatically adjust the image how you will change the game window. But if you have changed to 916, then it will keep that aspect ratio and change the window based on that. See, if I keep on making it small, it fixes the aspect ratio but keeps the screen as it is. It won't change the aspect ratio, right? So 9.9 is to 16 is the basic mobile aspect ratio, if you know. So this for Flappy Bird we are using this aspect ratio for mobile, right? Now, this was all this asset stuff I told before, and this prototype we'll be using. See, this is the board prototype, the board one. This is the image, the board, where you can we'll download it from the internet or to the website. It is easier to. This is the image, right? You see here, images in Unity are called sprite. The 2D images are called sprite. It's just the naming convention. So this is all the workaround. If you have any doubts, you can, or if you can't see any window, you can just go to window and find your game window all around this Unity. Okay. Now, so let's see the flowchart that we had in the previous week. So first, as I've shown you before, let me go through it in a brief. First, you hit play, and when the game starts, you set the board position to center. Now, all this stuff we'll be doing today. We will see how to do all of this. But first, let's see the flowchart once again. So first, you set the board's position to center. Then you initialize all script. This node means nothing but just start all the other scripts like pipe that comes, right. There are two pipes that randomly spawn in a random manner. So there is a script that is controlling that, right. It is waiting for a time. It is waiting for 2 to 3 seconds and spawning two pipes in a random position. So you can go through all of them once again, right. So this is the script that will be initializing. We will starting the script at the game start, so it won't mess around with your game, right? Now this flow goes to the update method. This update method is the one that is controlling everything: the input, the collision, and every other stuff that makes the player move. If there is no there is no update loop, the game or the bird will never move, right? So there is always an update loop that goes around in the game, and you can see in this next slide. that there are two parts in update. We will first check for input and second check for collision, right? We will first check for the input. We will check if the left mouse button or any button. If for mobile, you can check for touches. For PC, right now I am doing for left click or space keyboard. If it is pressed, then we will apply a force upwards. Else, we will just continue to the update loop. If we have applied the force to the upwards, we will still go back to update loop, right? We will end the game just when we have applied the force upward. We will still have to continue the game, right? Next, for the collision, we will check if the bird has collided with anything. Then we will show the score to the player and game over. If it hasn't collided, we'll just continue the game as normally, right? Now, this was the pseudocode that I had shown before. This is just for your understanding. Now, we'll just make a game. Now, this is just for a joke, not making a game. Now, first is we will take care of the visual part of the prototype, right? Now, as I said before, 2D images in Unity are called simple sprites, right? Now, sprite can be many of type. It can be a character image. It can be tiles. It can be tiles of your wall in your environment. It can be UI of your game. So all these things are called sprites. I will be using free and reusable images which are not copyrighted. Make sure in your mind that it should not be copyrighted. So I have found two websites which only upload a non reusable website and are not copyrighted. They are issued with a Creative Commons zero license, which states that it can be used anywhere. It can be reused. It can be remixed without giving any attribution or credit to the creator, right? So first was a open game art and second was the PNG Guru. So this image I got from open game art, right? It was really, I just searched open gameart.org. I just searched Flappy Bird and I got this Flappy Bird image. I also got this whole image from Flappy Bird as well. Right click and open this window. It will show you all this. See this I got from open game art also. This was a poll image for Flappy Bird. So now, if we'll see in the now we'll see how to start with the now. First, we will have to see how the code looks for the prototype, right? Before starting to use this powerful plugin, you will have to understand how the code works. Because the plugin is just a visual form of the script, like it is a visual scripting code. So before we start using that plugin, we will see the three scripts called movement, pipe, and pipe spawner. Right now, we will just look into movement and pipe spawner. I will send if you have any issues. So first, if I have created a piece of script. I have used Visual Studio Code for this development. You can use Visual Studio as well or Visual Studio Code if you are familiar with that. So you see, the first thing is importing the important namespaces, right? Using Unity engine. If this is not there, mono behavior might not be available. Rigid body might not be available to use. Start method, update method. You can't use any method use without using an Unity engine. Okay, Unity engine uses C# for the development process. So they have made their own complete namespace where you can just reference using Unity engine and you can just use start method, update method easily, right? So you see, these are the references in this game. The first is a variable called rigid body 2D with the name RB. This is the declaration of the variable. First is the access modifiers. Second is the class of the class or the variable type. Then we see it says rigid body physics component for 2D sprites. So the bird image is a 2D sprite, right? So it contains a rigid body 2D in this class. We will use rigid body 2D. If we have a 3D game, we will just use rigid body, right? We have named it RB right now. It is a just for references. Next is a variable velocity. Now, what velocity am I talking about right here? You will just go to the update method and you can see what velocity I'm talking. So this is the first line. If the input is another class of Unity engine where you can interface with the input system. Now, what can you reference from input? Input dot get key down. This is a function which will return true during the frame. That frame when the user has pressed the key down. See, there are different three types of input dot get key. There is get key down, get key up, and get key. So get key down is written true when you had pressed the button, right? This input get down is written true. Now when you have pressed the button and you have left up the button, it will use get key up. You can use get key up to get that. Now when you want to use a hold button, right? You will use get key. Simple. Now, key code is a enum where it has all the key codes for in your whole keyboard. Right now, I have reference dot space. I can reference all the multiple, for example, W, Shift, Control, Alt, all the keys I can reference. It will this line of code literally says that whenever you input is pressed, it will check for the input. If it is matching with the space input, then it will return true in get key down in this input function. So if this whole statement is true, then we want to apply a force upwards. Now how have I applied upwards? You will not be familiar with this, but I have referenced the velocity of the rigid body and I have given it a new velocity. What is the new velocity? I have given vector 2 dot up. See, up means nothing but 0 comma 1. It is a shorthand writing 0 comma 1. In Unity, if you see the axis, the left to right is the x-axis and the up to down is the y-axis. So to when we have pressed space, we want to move the bird in the upwards direction, right? So we have given it a 0 comma 1 multiplied with the velocity. Why haven't I directly written rb dot velocity equal to the variable velocity? Because we have to change the when we will, this is just for namesake. We have given it 1. It might not be 1, right? We will have to change it in the inspector. That is why I given it a public. So we will have to change the value of that variable and sort according to ourselves. So that is why I have given it a 0 comma 1. So anything multiplied with 1 will similarly be that value only, right? So just for namesakes, I have given vector 2 dot up, which is nothing but 0 comma 1 multiplied with the float value. So if you see vector comma 1, it is if you multiply vector 0 comma 1 with a float value, it multiplies to the every individual magnitude in the vector, right? So if I have given 2 over here, so this whole magnitude will be equal to vector. See here 0 comma 1 multiplied by 2 is 0 comma 2, right? This is also a vector 2. See, vector 2, linear velocity of the rigid body in units per second. So I have multiplied vector 2. I have given the reference to vector 2 in the velocity. So it will change the velocity according to how we will change over here. It won't stay stable or something. Now you will see how you can do all this stuff right now. Now let me create drag and drop this sprite. It is really easy. See, when I drag and drop this in the scene, it will create a game object of that name. See, bird. A bird game object has been created. It is really big right now. So let me create it. Let it scale to 0.1 and 0.1. How does it look? It's really small. So let's go to 0.15. 0.15. So this looks like a very decent bird size. So this is at the center. See, position 0 0. The camera is also at 0 0 right now, and the board is also at 0 0. So now let me just hide this graph inspector. We will see what we will do in this session. Go to step. Now this has only first component was transform, but when I dragged it into this scene, it automatically created a sprite under component. This is what shows that image into this scene, right? It takes the image. If I click on this, it will show me where is this image. It will show. See, it showed me this image was used in this sprite renderer, right? Now we will need to add multiple components to it as well. For example, if I start the game right now, it will just stay still. But if you want to add some gravity, we will be using the class, as I told before, rigid body 2D, for applying physics and all the gravity stuff. So you see, if you look into the options over here, the mass is 1, the linear drag, the gravity scale is 1. In 2D, it goes from 0 to 1. And if we had created a rigid body, just rigid body, 3D rigid body, it will just be allow gravity or not. It will be a tick mark just like here. But in 2D, you can change the gravity scale between 0 to 1. You can create 0.05, 0.5. The gravity scale you can change it in 2D. You can't change it in 3D because it is a fixed value. It will allow it just if you want to allow gravity or not. So this time it is gravity scale to 1. Now let me show you what happens when I start. Let me just pause the game right now because it will just start going right immediately. Now let me play the game. It might take some time because my PC is a little bit slow. Now we will be looking to the movement script. We have seen the movement script right now. We will be looking how this works in this practically. We will see how the game looks. Okay, just let it load for right now. See now when the game started, it faded to a black, so that you know you are in scene mode, right? If you change something in while you are in scene mode, then and when you stop playing, then the values will be changed back what were before the scene view. So this way you know that you are in the scene view, you are not in an editor view, right? So when I this time see it is not falling because I have paused the game right now. If you can't see, it is a little bit faded light, right? When I unpause this game, it will start falling down. See, as when I paused the game, the board started to fall down because the rigid body 2D was component was attached to it. See, so in Flappy Bird, what happens is that the board keeps on falling until you press space, right? I haven't attached the script to it right now. That is why it won't get the input and go upwards. Let's see again what happens when I start this game. See, this is a very useful tool in Unity. So you know that you are in scene view because if you change something in this scene view, you see the in the y-axis, this keeps on changing. It's going down and down until for all. Now this was just very simple. We have created a bird and we have added some components to it. Now let's also add the movement script, right? Right now I am showing you the script, but also we will see right now how to make this move script with the bolt plugin. See, okay, let me just drag the movement script so you know what we will be accomplishing in the end of this session. See, right now we have given two references: public rigid body (RB) and public float velocity. Now here it says none. If I just start playing the game, it will be giving me a error saying object reference not set to an instance of the object, right? Because it doesn't know what this is. But we are trying to access this velocity of that variable. Okay, so we'll have to give it a rigid body. You can give. There are two ways to give it. First, you can drag this into this field, or you can also use code to get that component in that where it is attached. See, movement will get that component in that object which is attached to. For example, see, movement is attached to this game object board. Now, if I use there's a script called rigid body is equal to get component of that class. Now, what does get component do? It searches in this list of components and finds the component that you are given rigid ball 2D and gives it to RB without you have to drag and drop into this field. But right now it is too confusing, so I will just drag and drop into this field. So this reference is given to the script. It can now access this rigid body of the bird object, and then it can apply force to the it can apply velocity to the bird. Now, if you when I'll pause the game and I'll play the game, you'll see the velocity is very low. It is 1. I am saying it a low because I have tried it and I will show you what happens when I have written 1. I will also start pressing space as well. So you can see a little bit. See, it's saying only a little bit is going up, right? You see, the gravity is applying too much, but the force is not applying upwards that much. That is why it is still going down and down. Okay, so the velocity right now is a little bit too slow. So let's up it to a 4. I think 4 looks really good. Let's pause the game and start the game again. Now, if you look, 4 is a little bit good. See, it is looking a bit much like Flappy Bird. See, when I'm pressing space, it is going a little bit up, right? Right now, if I don't press, it will just keep on going down. But when I press space, it goes a bit up because I have added, changed the value to 4. If I couldn't be able to change the value, it would still be going down and down. So when I change the value to 4, it looks a bit like Flappy Bird, but it's missing too much stuff. Right now, it's missing the pipes that come, two pipes that randomly spawn at a variable counter. Then when it hits the ground, it ends the game. Right now, it isn't ending the game. See this now. This is the good thing about game development. You can see what is going behind the scenes. See, if I keep on going up, you can see in the scene view that it is out of the game, but the actual scene where you use your mobile, you don't know what is happening in the behind, right? So you can trick the people into what's going in the game. You will see in this session what is the trick that I'm going to use to make Flappy Bird really fun. Let's just stop the game right now. Now we have seen all this this code. This is a really simple code. See, Flappy Bird was made in 3 days, as I've known, as the facts that I know, and it has become the fastest downloading game on Play Store and App Store. It was really made in 3 days, so it was really an accomplishment. And it was. I don't think it was made in Unity. It was made by the person himself. He made his own game engine, right? So you see, you saw how the code works in this game, right? Now let me show you how to make that exact. See, now we will try to create the exact same code in a visual form. But we will use Bolt, a visual scripting tool, where we will easily connect those nodes and we will make a flowchart type of a flowchart or a game flow of your game. And every node in that tool, every node you see, every connecting node is may or may not be a line of the code in that script. Now let me explain you what I'm meaning to say. Let's just delete the script right now. We'll just remove the script, not delete it. We'll remove the component of the script, so it is just removed off. Now, to use that bold plugin in any game object, you will have to add a new component from here called a flow machine. So this is the flow machine which controls the flowchart of this object, right? So it is asking for a macro. Macro is nothing but this thing, a new function, a new class that will be controlling a new script, for example. When I created a new script in movement, it was created with some stuff. So similarly, the macro for a flow machine is nothing but a script. It is asking for a script. Right now, it is given here as none, right? So I will just drag and drop this move script that I created. If you haven't created, you can just create a new. See, there is a new button. Okay. Now, what was the first thing that we created in the script? The rigid body. Now, as I said, rigid body can be accessed from two types. You can get it from get component, or you can access it using drag and drop. Now, when we had a script, we could make the field as public and drag and drop them into the script. As I told before, you could drag the rigid body into that script. But here, there is no thing to drag it into, right? So we will have to use the thing that I told before, get component, which will get the component list and it will get the main component that matches which you have given at that time. Okay. So if you go to the move and edit graph, see anything in this flow machine, the Bolt plugin is a graph. Okay, when I click on edit graph, see two things are created: start event and update event. This was the exact same event which I created when I created a new script in Unity, not a new flow machine. Whenever I created a new movement script or new any other scripts, so you see these two scripts, these two methods are already there. I just added this two lines and this line. So these two methods are already there. Similarly, it is just a visual form of that script only. That is what I am trying to make you understand. Bolt is nothing. It is not a drag and drop tool. It is a visual scripting tool where you take all the code, where people who are not familiar with coding can understand and learn coding with this plugin. So it is a visual form of that script only. If you see the side by side here, this script, this is all the extra stuff in this script. All this is managed by Bolt. You don't need to see all this class and using it is already there. But see, start and update. There are two functions already created. You don't need to do. There are two nodes already created, right? So first, what is the first? As I told before, rigid body. We won't be using this variable in the flowchart. Now we will need a velocity variable to change the variable as per our choice. So if I go back to the bird object, and I see the inspector. You see, there is a variable component automatically created when I created a flow machine. Now let's say it velocity name. Next hit plus. It will ask for the type. Right now it is null. So what was the type for our game? It was a float or double decimal value. So see, right now it is getting all these values. There are multiple values. See, there are global enums. There are multiple values, but the five base values are game object, float, integer, string, boolean, and vector 2. Right now we are in 2D mode. That is why the vector 2 is giving us right now vector 2. So we need a float right now, right? Now, when we created a float value, it used for a value, the initial value, right? What you want. Let's create a one value as we had done before. Now, when we go back to this flow graph, and now I'll be switching to the code editor as well as the Unity Bolt plugin, so that you can understand the every line and every node in this game. We'll take every line and create a new node in the Bolt plugin, so you understand there's nothing but a visual scripting. See, the first update in the start, I have written anything because we don't need to initialize in this moment right now. First is the update method. See, in the update method, I have given the first line if there's a function. It is the first thing. We don't need to look right now into this. The first thing that comes into Unity, the whenever the execution start in this function, from this line to this line, there is a if statement. So to create an if statement in this node, what you do is you right click, it automatically creates a whole list of all these things where you can access from the menu, or you can search for this. So for an if statement, you see control. The control statement, if you go and see the branch, this is nothing but see branches flow by checking if a condition is true or false. That is what we need right now. See, there is a switch statement, switch on enum, switch on string, switch case. If you are familiar with switch case, this is nothing but switch case. This select on enum, for loop, for each loop, while, break loop. All these things are flow, nothing but the code, but given in a visual form. So right now we are looking into branch. Okay. So why did I deleted the graph inspector? To show you what happens in this what does the every node mean, right? So let's see. When I click on the branch, it shows branches flow by checking if a condition is true or false. Now, if you look closely, there are four things. There is a inwards coming arrow. There is an outward going arrow. There are two outward going arrow. If it is true, it goes this. If it's true, it goes here. And this, what is this? If you look here, the first is a enter, the entry point of this branch. The entry point. If you want to start now, as we seen, this entry from here goes to this line. So this should go to this node, right? So when I didn't have this, I didn't have this node right now. See, it was dull. So it shows that it wasn't used in this game. Whenever I just added the flow to it, it came into view and showed that it is being used in the game. So the first was an inward flow. Now when I again click into this, it says the condition to check. Now what do the condition do I need to check? if the input dot get key down, the in that get key down, if the key is space, so how can you access that into this bold plugin? Similarly, just click on the outside, right click. Now, as I've shown you the code, search the exact same thing. If I search input space get key down, it is searching all over the plugin that is at C. There are two types. Get key, the key code, if as I've shown, key code dot space, or by the space, by the name of the key. But the name is not no, efficient because every keyboard is different, cannot be every different, but the ASCII value of the key is same, right? So we'll be using key code of that key. So you see, what is the thing that is uses here? A key code, a key. Now whenever I open this none, you see all the keys that you can use are shown over here. Right now we'll use space as I've shown before. It's space. Now what does this say? When I click on this, the invoke method, right now we don't need to look into it. The key code, we have selected the key code. The exit of the flow, we don't need to go through this this is just a statement, right? It is not an execution line, it is just a statement in the if condition. So if you use the last purple method, it says the result of that thing. Now what does the result mean? If the key is pressed down, it will come out as true, else it will come out as false. So you see this, if I put it over here, it won't take it. Why? Because it takes a similar type only, right? So it will start creating a new one for me. Now, if I see, it will only take a condition, Boolean condition. Here also Boolean condition, here a Boolean condition. It will only take a Boolean condition into it. Now, if you go to the code again, the first line that we had, we created into two nodes. See, the first one was a if condition, and in that if condition, what is the condition that you want? You are given a if condition, but what is the condition? The condition is that if the input is given a key down, well, and what key? We will use the space key. If the space key is pressed down, we want to go, if it is given true, now it will go true, it will go into this condition is true. Now if this is true, we will have to create another thing. What? Rigid body dot velocity equal to vector 2 dot up multiplied by the velocity variable, right? So how can you achieve that? It's nothing. You just search again, that as I searched before. Search rigid body velocity. Rigid body. Let's see, rigid body 2D velocity. Now you see there are multiple. There is a get velocity, there is a set velocity. What are we doing in this code? We are setting the velocity. See, we are giving a value to the velocity. So we are setting the velocity. So we will use set velocity in this in that flow machine, right? Rigid body 2D velocity. See, we will use set velocity. Now what does set velocity use? It needs a value, it needs a vector to value, right? So as I've shown before, it is a vector to, it needs a vector to value. So see, it is a set value. Now we will have to also go to here. The flow should be maintained. What I am trying to understand is the flow should be maintained. The code grows from, see, if I show you in a visual form, the update function gets called. The line of execution goes to this statement. If this statement is true, the line of execution goes to this statement. If this is false, it goes nowhere. It's just calling update, update, and update. If this nothing is happening. But if the line of execution goes to here, it checks. If it is true, then do this. If else, there is no else statement. It will do nothing. So the line of execution goes from update to if to this statement. Similarly, if you go here, the line of execution goes from update to the branch. Branch is nothing but an if statement. Again, similarly, if it is true, you want to set the velocity. But what value, right? So it is given a value. You see, this marks a vector 2, left and right. So it is a 0, 0 value. But what do we need to give it? We need to give it vector 2 dot up multiplied with the velocity. You can easily access, as I have shown again. you can easily access vector2 data from that list. Okay, so this was a shortcut for opening it a full screen. If you hit control space in that window, the window that is right now here, if you hit control space, it gets maximized, or if it is maximized, it gets minimized. This was a shortcut for using that in Unity. So we'll just use search vector2.up. See, it says get up. If you see down, it says shorthand for writing vector2. If you don't see, if you want to read it again, you can click on it and you can see in the graph inspector. Shorthand for writing vector2 0, 1. It is nothing but up. Now we have got the up. What does this get up give? It gives us a vector2 0, 1. Now we need to multiply with the variable that we created in the script. But in this in this graph, what have we created? We have created a flow motion variable, right? We created a variable right here. Now you can drag and drop that into this flow machine. It will automatically create a node called get variable. Right? See, it will get a variable called get variable. Let me just maximize it so you can easily see that. See, it creates a new variable called get variable. Now we need to multiply these two. So similarly, just search for multiply. Now there are multiple, see, generic scalar. You see the first value is okay. If I go to if I click here and if I hit vector2, we will convert the variable velocity into a vector2, right? We will use expose vector. It will use that variable and it will give it out a vector to us. Now there is a really big vector2 because it has exposed all the variable in that vector2. You see everything, right? So we'll just use right now we'll use vector. Let's just delete this. See here we create a vector from that variable. We have given it a value of let's give it a value in the y direction, right? Okay, where has this gone away? Okay, let's just create a simple create a new flow machine. I think it is broken. Let's create a new macro, new macro script. It will open a window to say it where do you want to save that macro. You just use move player. Now see this move player, if I hit on edit graph, it will again open this graph. Let's go to the it once again. We'll open a branch from this. Okay, so we got the branch. Now we need to get the input out of it, right? So let's get input, get key down. Now from that key, we'll need the space keyboard. We will give that boolean to that branch. We will also need a rigid body, get set velocity. Now we got the set velocity right now over here. We need a vector 2, right? So we will get the vector 2 dot up, multiply it with the let's add another multiply value. So we got the first value get up, and we'll give it to the set velocity over here. We'll also have to give it the flow over here. So the flow is maintained. The every node is used in this game. Now let's we'll create a velocity variable as we had shown before. We'll use the float variable and give it a value of 4. We'll drag it into this scene so you can access that variable. So you see everything has been used in this flow. Let me maximize it to show you. So you see everything in this view is used in this game. Every node is used, so you know to debug your game easily. That if anything is not used, you can easily debug your game. So you see what I will explain it again. We have given a branch over here. If it is the import is space is pressed, we will go to setting the velocity. But what velocity you will to set? We will set it to a new velocity called multiplied by the variable multiplied by the 0, 1. So it stays in a vector 2 value, because if you multiply, if we can't give a vector to a float, right? We can't just add rigid body velocity equal to velocity, because it will conflict. The velocity is a float value and it uses a vector 2 value. So we had to create a vector 2 from that float with a value 0, 8. We'll multiply with 0, 1 and into 0, 8. and we will get that, give it the value to the set velocity. We just dock this into the top over here, so you can change this value. Now you can, when I play this game, you can also see that everything flows one to one over here. See, when I'll start the game, you will automatically see that the flow goes. You can visually see where the flow goes in every frame, every second where the flow goes. Right. Okay, so the game has started. See, now I won't press space right now, but you can see every dot that shows that everything is going over here. And see, the update is going to the branch, but there is no true right now because I haven't pressed anything, and the board has fallen, and it is still falling down. The board is still falling down. I haven't pressed any button. That is why it is giving a false value. See, it is giving a false value right now, but we haven't given it anything for a false value. For the false, if the function is if the branch value, if the condition is false, we haven't give it. We haven't told anything to do for a false, so it will do it. It won't do anything. Or but for a true, we have given it something, right? So let's just start the game again. And right now, I don't think it will work, but we'll just test it. You see, it's still working. See, whenever I am pressing space, the value you see, this is getting used. See, every for one frame only, not for every time. Whenever I am pressing hitting space, the value is being used. Whenever I am hitting space, it is being used. When I don't use hit space, it is not being used. So the flow is still at over here when I'm not pressing anything. Whenever I press the space, every other node is being used in this bolt plugin. So you see, whenever hitting space, a dot goes from here to here, which calls all these nodes to get that value, right? So you see, this everything is going up and up whenever I'm hitting space. So we have accomplished the same thing that we had in the script. Similarly, we have accomplished it in Bolt plugin, right? So now for this, the Flappy Bird is not yet complete, but I have just shown you the base movement script. There are multiple scripts. Let me show you the pipe script right now. But before that, I will show you the whole game that I have completed with the script. Let's save this scene right now and open the scene that I had been working. Okay. Now let me maximize the game view so that it is focused more. And I have created this whole game. You see, every pole I have it is spawning for every multiple time, and it is changing. The position keeps on changing on a random value that I haven't created. There is still more stuff. For example, when I'm colliding, it still goes up. See, the game is still going up whenever I'm colliding with the poles or the board is colliding with the poles. So it is tough because it is a circle collider, right? So right now, see, it is still whenever applying velocity, physics is applied to the body because it is a rigid body. So when it is physics is applied, see, it is still going on. Now, the trick that I was talking about in the previous slide, games trick you in thinking that this is the right way, this is what is going on, but it is not necessarily not going the way that you are thinking. If I focus on the board right now and I show you what happening. Okay, so the trick that over here is when I'll hit play, you can easily see. You see, the poles are spawning and they are coming towards me. The board is not moving. The board is staying still where it was. The board is still stay. This is still. the thing that is coming towards this is the poles, right? The trick that is tricking everyone that the bird is going towards the pole. That is not necessarily the case. It might be going for every game is different, right? For Flappy Bird, they might have done that, but this time I used a simple trick where the poles are coming towards you, then the bird is staying still. The bird is not even moving left or right. It is just moving as you have seen the movement script. It is only moving towards up or down, right? The camera of the game is not moving. The poles are coming towards the player, right? Now, if you want to see how I created this script, you can. I will show you right now. There are two things. First is the pole ground, which has a collider. You see, the in the previous one I didn't show you, but see, if I look, the green circle is a circle collider. See, a circle collider is attached to the game object board, where if any other collider attached to it, it stays. If I it hadn't attached any collider, it would pass through every object and keep on falling down. If I go to the ground, I used a pole just for the ground. So you see, it also has a box collider. If I hit on edit, you see it shows the box collider that is being used. Similarly, if I see, I have also used the prefab as I've shown in the previous week. The prefab is used to spawn everything. For example, I have showed you that poles are spawning at every individual time and every random point. So I created a pole object, an empty object. I dragged it to, if I drag it to here, you see, this game object is blue because it is a prefab. This is blue, this is because it is a prefab. So the pole is an empty game object which uses a pole pipe move script. It moves the pipe to the left at a certain speed, right? Now there are two game objects inside it. There is a lower pole and there is a upper pole. So these both have, there is nothing to have with the script. It just uses a box collider and a sprite renderer. Everything is controlled by the parent game object. So I have attached these two into the game view, and I have adjusted it so that the bird can easily go around it in the easiest manner, right? So let's see the script what I have done. Let's see the pipe movement script right now. First we'll see the pipe movement, and then we'll see the pipe spawner, which will spawn pipes at different rates. You see, it is very simple. You can also create a pipe move with the bolt plugin, as I've shown before. Now, what is happening over here? I've created a speed variable, right? The speed variable will be easily for your sake. You can adjust the speed of that pipe move. As I right now, I have set it to 1.5, right? If you go to the pipe, you see when I inspect it over the inspector, it will show that speed is 1.5. Now, what is happening in the update? Transformed position. Now, this is a very important term, transformed position. What is transformed position in this scene view? If I drag it into here and I'll show you. The pole is a game object. The script that is accessing transformed position is attached to the game object right here. Now, what is it trying to do? Transformed position nothing means this transform component dot position. This position I want to change. Now I haven't referenced it over here because it is inbuilt. You can easily access transform position because it is a you have to use multiple times transform position to move any object. But for rigid body you don't need to use it multiple times. That is why I have referenced it a new rigid body and used the reference over here. But in Unity, transformed position is already in this game object class, right? So as in the previous week I told you, mono behavior is a base class for everything. So mono behavior has a reference to transformed position already in that the transform attached to this game object it is accessing. The transform class attached to this game object. So the script that is attached to the game object that game objects transform, right? What is it changing? Transformed position. It is plus equals. This is a shorthand for transformed position equal to transformed position plus this value. So what is it doing? It is plus equal to a specific value. It is accessing this x and y coordinates, and it is now transform is a vector 3. It is not a vector 2. So we will have to give it a vector 3 dot left. It won't take a vector 2 or it will give you an error. because everything, if I show you, everything in Unity exists in a 3D space. If I there's a 2D view, if I try to change it to 3D view, you see everything is in 3D view. Just for showing you for the easier express of your work, it has changed 2D view, or else it is in 3D view. See the z-axis. It doesn't matter. See, the game view doesn't changes when I change the z-axis, but it changes when I changes the x-axis or the y-axis. The z-axis doesn't change because it is straight pointing towards the screen to me, right? So if I go upwards or backward, it doesn't changes anything. Let's just get it back. Right. So I will. This is just for seeing the same view in 2D view or 3D view. Everything in Unity is still in 3D view only, right? So for changing to 2D, I'll just hit to change it to 2D view for easily managing my scene. Now, what is it changing? It is taking vector 3 dot left. Now, let's see what vector 3 dot left is again right now. Now, I'll also again show you the axis right once again. Now, if you see x-axis, see the x-axis is left to right. This is right, this is left. Okay. Z-axis forward, backward. Then y-axis up and down. This is what the references all the vectors. So when we are spawning the pipe over here, when for every frame we want to move it to the left. So we have given it a vector. We have multiplied the speed vector with a vector 3 dot left. So if you see here, the representation of 3D vectors. See the shorthand for writing vector 3. Now -1 is nothing but left in x. If plus is right, then minus is left, right? So first this is left, this is right, this is left. So we are multiplying with the speed value, a float value, multiplied by the vector value is nothing but minus the value of the speed, comma 0 0. Now what is this new variable called time or delta time? This variable is used for making your game frame rate independent. For example, if I hadn't used this in the game, it would lag the game too much when you had a when you had a low end PC. Right now, it is not important, but it is really useful when you have created a big game. When you want to update something in reference to the time, right? So I have used time dot delta time because it is frame rate independent. So when the frame rate changes, it automatically changes the game as per the framework. For example, if I have the framework is 60 FPS per second, the time to delta time will multiply the speed variable and keep the speed as in that frame rate, right? For example, is 30 frames per second, it will half the delta time. It will automatically change the speed of the value on basis of the frame rate. So if you have a high-end PC and it is 140 FPS, the speed will increase. If it is a low-end PC, it will go based on the frames per second of your PC. Now let's go back to 2D view and delete the pole right now. As I see, the speed is 1.5. Now the main thing is the pole spawner. The main manager type of pipe. See, the first thing that I have referenced is the max time. The waiting time between two poles spawn, right? For the first time it will spawn a pipe, it will wait for some time and then it will spawn the pipe. So the waiting time between those two pipes is given as max time. The counter I have given a private variable which you don't need to access it. It is a counter timer. It will count the time and it will accordingly change the pipe spawning. Then this is a game object. What do you want to spawn? This says the game object pipe. The pipe object that we had made into a prefab. Now we can drag and drop into the script when I will show you, and we can easily spawn that thing into the scene view. That is how you can spawn multiple prefab into a scene view using scripts. And this is the height of the pipe that will be spawned. So I'll show you right now. You see in the first start, I have spawned the pipe. Let's go to the spawn pipe. What does it say? It says that create a new game object called new pipe. What is that equal to? Instantiate. Let's see what it says. Instantiate is nothing but it will create a game object. It will create something that is given into it. It will create the game object given to it into the scene view, right? So if you had seen before, it was creating multiple pole with a bracket clone, right? It was written clone in the bracket. I'll show you when I play the game. But when what instantiate does is it creates a new pipe whenever you call instantiate, right? It creates new game objects whenever you give it the game object it requires. Now, why if I can also use without these things, I can just use instantiate pipe. But why have I given it to a game object? I have given it because I want to change the position of it. I don't want to keep the position similar all the time. See, in this is the main line. New pipe dot transform the new game object. That game object's transform dot position. I want to create a new position to it. What I want to give? I want to give this position, the pole's position plus a new vector 3. Now, what does it new vector 3 say? It says 0 in the x-axis. We have to change it in the y-axis, right? Up or down. We have to change it in random value. So, random.range, what does it do? Class for generating random data. And random range, it returns a random float number between minimum inclusive, which means minus height is included and max inclusive, which is also included also. So it will create a random value every time this function is called to create a random value between these 2 points, minus height and plus height, and the z is also 0. Then this will destroy the pipe as well. Now see, instantiate and destroy come together. When you instantiate something, you should also destroy it, or else your game will start lagging too much because there are multiple game objects into your scene. So what does destroy do? Destroy it needs a object. It can be a game object, it can be any object in the scene, and it needs a float t. Now it removes a game object, component, or asset. Now float t is nothing but a time in a delay. So in how much time do you want to destroy it? When this destroy function is called, it will start counting for 15 seconds, and it will destroy the pipe after 15 seconds, right? So this was the spawn pipe function. Now let's see the start. I want to spawn the first pipe, right? First one I have to spawn. Then update function. This is the main part. If timer is greater than max time. Let's not go over this if statement. This is for just right now. Let's see this here. Timer plus equals to time to delta time. To every frame I'm adding the counter by delta time. The timer is increasing every frame, right? Now, when this every frame is going on, it is also checking if the timer has been greater than max time. For example, it will be counting in milliseconds right now, time to delta time right now. So when the millisecond is greater than 2 seconds, see, for example, this scene for the pole spawner, I have given the max time as 2 seconds. So when the time is been plus for every frame, when the time is greater than 2, we will spawn the pipe and we will now set the timer to 0. So we will start counting from 0 again. Understand? So this is the basic spawning system in a game. You create a waiting time, you create a counter time, and you create something what you want to create, what you want to spawn in the game. So counter is being count every frame in the update. Then we are also checking while we are plusing it, we are checking if it has grown greater than 2, the max time or the waiting time of that spawning system. If it has, then we will spawn the pipe and we will set the timer to 0. We will then again it will then again keep on going on and on until there is no until the game has been over or the player has been hit by the poles. So this is a really good endless system in the game. So I have done every. Now let's see what I'm trying to show you. The max time waiting is 2 seconds. The height is 0.5. So it will see this is a 0, center is a 0 0, right? The center is 0 0. So 0.5 is here. So between these 2 points, it will randomly generate a point. It will spawn the position between spawn the poles at that point at that instant. Let's play the game once again and show you what is happening in the scene, background scene. Let's zoom out a bit so you understand what is going on in this game. Now see, poles are being spawned every 2 seconds, and they are randomly based on the height that I have given. And see, the first look at the first pole that is spawned. It was spawned, and when it is reached the 15-second limit, it will destroy automatically. You see, they are getting destroyed every 15 seconds whenever they are spawned. The time when they are spawned, the 15-second counter starts, and when the 15-second counter is finished, they destroy themselves by the code that we had written. Right. So you see this rotation, it keeps on rotating. We can fix it right now. We'll see it now. See, this is the game, complete game. Keeps on falling. The game has been over. If it hits something, it see the player is going down. Now see, this keeps on going endless. You can play it multiple times. There is no limit for the code because the code is really good, and it is comprised of complete game right now. So you see, I saw that clones that were created. It was because of the instantiate method that we created. So now I hope you can create this script. I hope you can create this script using the Bolt plugin as I showed before. You just need to search everything every line of code that I've shown. If it is written transformed position, you need to search transform space position because you might not find in the first place, right? This I have created a script